Hello, we are going to do the work and power calculation notes today. Let's start by writing down your essential question. So your essential question is, what are work and power and how are they related? And then how do we calculate them? So there are two new vocab words, work and power. Those are what we're going to be calculating today. And we're also going to be defining them. So the first thing is, what does work mean? So we can think of homework and schoolwork, and I go to a job and do my work. But we want to know, what is the scientific meaning of work? So oftentimes there are words in science that we use in our everyday lives, but they mean something different when we're looking at them in science. Work is one of those words. So work is the force applied over a certain distance. So what this means is that if there is movement, because there has to be a distance, and if someone is applying a force, this is when work happens. So in order for there to be work, there has to be a couple of things. The force has to be in the same direction as motion. So you can see in this picture here, he's pushing the mower to the right, and the distance it's moving is to the right as well. So since he's pushing to the right and the mower is moving to the right, work is being done. If there's no motion, there's no work. So work has to be a force applied over a certain distance. So if there's no distance, there can be no work, which means that our third piece, if you're holding something up, there's no work because there's no motion. So you can hold something up all day and it can be really tiring. But if you're just holding it in the same place, there's not actually any work that's occurring. This has to do with the first part of this, that the force has to be in the same direction as motion. So if we look at this picture here, this person is carrying a backpack and walking down the hallway. So we think, okay, there's movement. He's holding up a backpack. But the problem is that his force is upward. He's holding up that backpack, but his direction of movement is to the left side of the screen. So remember, our very first rule, our very first thing to remember is that the force and the direction of movement have to be the same. So since these arrows go in two different directions, there's no work in this scenario. So of course we can calculate what work is. Work is equal to force times distance. The units of work are joules. This is a new unit for us. Joules is a way that we can measure energy. Force is in newtons. That's from our last chapter. And then the distance we're going to measure in meters. So it's a 3-variable equation, which means that we can have a triangle. So work is on the top, and then force and distance. Notice it's a capital W for work, lowercase d. So let's try a few of these. So when we're going to solve these, the very first thing we need to ask is there any work being done? So when we analyze the problem, we have to think about the direction of the force. It has to be the same as the direction of the motion. If not, there's no work. The work is going to be equal to 0. Another scenario, there has to be motion. There has to be some sort of movement. If there's no movement, there also would be no work. Okay, so first question, how much work is done when a weightlifter lifts a barbell with a weight of 1,300 newtons, a distance of 1.5 meters? So I don't see force here, but I see this newton. Remember in our Beanie Baby lab, we wanted to calculate the weight of our Beanie Baby. And we found out that the weight is actually a force. It's the force of our bodies downward. So in these practice problems, when you see the word weight, weight is just another way of saying force. So for this one, the question is, how much work is being done? So first, was there work? So we've got a weightlifter lifting a barbell, and it's moving 1.5 meters. So he maybe is pulling the barbell up, and it's moving up. So yes, there was work. So We can use the equation work equals force times distance. On my triangle, if I cover up the W, I'm left with F and D next to each other. We multiply things that are next to each other. Next, I'm going to define my variables. So my force is 1,300 newtons, and it moves a distance of 1.5 meters. So I've done the hard work. Now I'm going to plug those values into my equation. So work is equal to 1,300 newtons times 1.5 meters. And that's going to be 1,950 joules. So we've been practicing this whole trimester canceling units and crossing things out, and it just doesn't work in this chapter or in this section. So we will need to memorize that force has to be in newtons, distance has to be in meters, and that will leave us a work in joules. They just don't cancel out. Okay, let's try another one. How much work is done pushing a car 2 meters if its weight is 3,000 newtons? So we always want to ask ourselves, is there work being done? Okay, so I'm pushing a car 2 meters and its weight is 3,000 newtons. So I need to push that much. So yes, I'm applying a force. So work equals force times distance. My force was 3,000 newtons to get that car moving. And the distance it moves is 2 meters. So I can go ahead and plug my values in. 3,000 newtons times 2 meters. That's 6,000 joules. Okay, now you guys, how much work is done pushing that same car if it doesn't move? So remember, one of the requirements for work to be done is there has to be movement, and it has to be in the direction of the force. So if we were to forget about checking and we said work equals force times distance, our force is 3,000 newtons, it's that same car, but our distance is 0 meters. Anytime that you multiply something by 0, you end up getting 0 for an answer. So because there wasn't a distance moved, my work here is 0. Okay, you guys, I want you to try this one on your own. So pause the video and take a second to work through it. How much work is done picking a baby up 2.5 meters off the ground if the baby has a weight of 100 newtons? Okay, try this one. Hopefully you actually stopped the video and tried it. So this is what I found. It's asking how much work is done. So work is equal to force times distance. My force is 100 newtons, and I moved that baby 2.5 meters. So when I multiply 100 times 2.5, I end up with 250 joules of work. Okay. To piggyback on that one, how much work does it take to carry that baby 10 meters? So remember, you guys, this was one of our specific situations. There is no work to carry an object. Your force is up, but the distance is forward. So in order for you to have done work, the force and the distance have to be in the same direction. You're holding that baby up, but you're moving 10 meters across the room. So that would be no work done.